Geometry? Welcome back. We're studying G3, which is Symmetry, Transformations, and Coordinate Applications. Alright, your goal at the end of this is that you will be able to solve problems involving symmetry and transformations. This will include investigating symmetry and determining whether a figure is symmetric with respect to a line or a point. Let's go ahead and knock it out. This is all review for you. You've seen this before, so it should jog your memory. There's some things I want to concentrate on as you get prepared for your final test. Other than that, let's go. So, recall the definitions of point symmetry, rotational symmetry, and line symmetry. What does it mean for a shape to have symmetry about a point? If I give you an example of an hourglass, how do you know that that has symmetry about a point? Keep thinking about the symmetry with the line. What is line symmetry? Okay, how does that apply to different shapes that you know? Look at the alphabet, go to the alphabet and see which letters have line symmetry. Can I draw a line and get the same shape on both sides? That's all it is. Let's look here at these examples. Okay, you see in group 1, okay, example A, example 2, example 3, and example 4 all have some type of symmetry. In fact, example 4 has multiple lines. Now let's look down here at the bottom. Example 3 does not have symmetry, and we would all expect a parallelogram to have symmetry. However, when you fold it, the corners stick past each other. So, like I said earlier, use the alphabet, use some shapes in your house, pick up some things, you're there chilling, all right? And look for some symmetry. Let's go ahead and skip to your transformations, which are the fun things. Okay, now, when we were in class, we did all our transformations by hand. Now, I'm going to teach you how to do transformations using Desmos, okay? The thing I need you to know the most, or remember the most, and pause this video if you need to, and write down these rules, okay? The rules for rotation. One thing you need to pay attention to is that the left side deals with being counterclockwise, and the right side deals with clockwise rotations, okay? So, if you are rotating 90 degrees counterclockwise, it is the same thing as to say I rotate 270 degrees clockwise, okay? Draw a little coordinate plane, if you can, to kind of give yourself a better understanding of what I'm saying. All right, I'll even draw one for you right now, impromptu, okay? If I say coordinate plane as such, and I start here, 90 degrees counterclockwise will land me here. 270 degrees will also land me in the same quadrant. That's what I'm explaining to you. Trick question. Why does 180 degrees land you in the same spot? Okay, in addition to rotations, let's look at reflections. There are some rules for reflections. As you reflect across the x-axis, the y values become negative. Okay, you reflect across the y-axis, your x values become negative. Just think of that. If I start above the x-axis and I go below it, my values become negative. If I reflect across the line y equals x, consider that just flipping the y and the x positions. So x's become y's and y's become x's. Same thing happens with across the line of y equals negative x. However, we also negate those values. We have 2 more transformations to learn. Those are translations, where we have x, y, and they become x plus k and y plus h, which means I either shift up or down with the y value, or left and right with the x value. And the last thing we have are dilations. Dilations either get bigger or smaller. Okay, let's go ahead and see some practice. So what I'm going to do is open up a Desmos window, and I'm going to show you how to do a reflection in Desmos using the word polygon. It's this simple. My goal is to reflect quadrilateral ABCD across the line y equals negative x. And I'm also going to graph y equals negative x for you so that you can understand the true reflection. So, quadrilateral, I type in the word polygon, and then I type in the coordinates. The coordinates are 2, 1, 5, negative 2, 5, 2, 6, negative 1, and 3, negative 7. So I type that in, and as we see here, they drew me a polygon. Now my goal is to reflect it across y equals negative x. The only task that you have to understand right now are what are the rules for reflection. So I'm going to type polygon in again, and the rules of reflection across y equals negative x say to change or interchange y and x and make them both negative. So if I interchange 2 and 1 and make it both negative, that becomes negative 1, comma negative 2. Close that parentheses. Let's go to the next one. How does 5 and 2 follow these rules? Okay, change it to -2, comma, -5. All right, let's keep it going. 6, comma, -1. It's tricky because 1 is already negative. So if I have to negate that, 2 negatives make a positive. Good job. Okay, and then it's 1, comma, -6. Our last one is going to be 3, -7, reverse to +7, comma, -3. Here, Desmos has already graphed this for us. We have our original polygon, okay, and we have our new reflected polygon across y equals -x, and the blue line is showing you that. Okay, if you look on Schoology, there's a practice set of questions that allow you to practice reflecting and transformations. This is not hard, it's just something different because you're used to doing it by hand, but you do have the skill set to get this done. All right, check out the next video so you can do some practice rotations.